This is mathheals.com, where you can find more links to YouTube math videos if you're interested. Let's take a look. Let me close this other one down. Let's take a look at factoring special products. Now, just to refresh your memory on our different factoring techniques that we've looked at so far. Our first one is GCF, the greatest common factor. And I'll put an asterisk by it because we always try to do that one. Now, grouping, you do when you have 4 or more terms. Our third one is the PSD method. And that's when you have the form x squared plus bx plus c. And our fourth method is the key number. And that's when you got the form ax squared plus bx plus c. Our fifth method is dots, difference of two squares. And this is two terms with a minus between them. So two terms with a minus between them. Now our sixth one is the difference of two cubes. And this is two terms with a minus between them. Now notice that description is the same as the one right above it. Basically, if difference of two squares fails, then you come down and use difference of two cubes. And then our seventh one is the sum of two cubes. And this is two terms with a plus between them. Now, the ones we're going to be looking at here in this lesson are the number 5, 6, and 7. So those last three. Now, this first one isn't in the list. I'm going to talk about it. So I got one, first problem, we got m squared plus 14m plus 49. It says factor each perfect square trinomial. I don't really like this method very well. The few times you can use it, and it's not very many, people never remember it anyway. And we already can do it with one of these other methods. Well, let's start going through these. I'll first do it using one of the other methods, then I'll use a perfect square trinomial. If you're a math major, you probably need to see it. GCF, there isn't any. Grouping, 4 more terms. Doesn't fit, there's 3 terms. PSD, different variable, but m squared, m, no m, and there's no number in front of the m squared. So that's our PSD. Well, we'll take the number at the end, the 49, and we'll come up with 3 columns. Our P column, our S column, and our D column. The P column is all products give us 49. Well, we got 1 times 49, 2, no, 3, no, 4, no, 5, 6, 7. 7 times 7. And the S column, we're going to add these together. 1 plus 49 is 50. 7 plus 7 is 14. In the difference column, we subtract them. 49 minus 1 is 48. 7 minus 7 is 0. PSD method, the number we're looking for is the number in the middle, on the middle term, which is 14. So we're going to use 7 and 7. Now our larger number, and they're both the same here, but our larger number is the same size as our middle term. So one of the 7s be the same size as the middle term. We've got a 7 here and 7 here. So this will be positive. The number I circled in the S column, S for same signs. So if this one's positive, then this one's positive. So our answer is just the m plus 7 squared. Okay, let's look at the perfect square trinomial. if we got m squared plus 14m plus 49. Now, this right here is m times m. And this one is 7 times 7. That has to be true for this to work, by the way. You have to be able to rewrite the first term as something times itself and rewrite this one as something times itself. Now, the big question is, for this middle term here, if you can get the middle term by taking 2 times one of the m's times one of the 7's, then that's a perfect square trinomial. Well, this is, I'll write the formula down here in a minute, but I see that if I take 2 times 7, that's 14, so 14m, so that gives us the middle. So what the formula says is we can rewrite this as putting the m here, so one of these m's comes down here, one of these 7's comes down right here, this is always squared, and the sign in the middle will be a plus. And then that's our answer. I don't think it's any easier than the PSD method or key number, depending upon what it looks like. And sometimes you run across a real hideous one where it does save you a little bit of steps. But considering there's probably only 1 or 2 in an entire college algebra book, there might be a few more in intermediate algebra. But it doesn't happen very often. The formulas for it, if you're into formulas. And the worst part of it is your signs have to be just right for this to work. So your perfect square trinomial looks like this. I guess I'll use a's as good as anything. So you got a squared, and over here we have b squared, and then here we'll have plus 2ab. Well, if you got it in that form, you can rewrite this as a plus b squared. Well, what this says is that a and b can be anything. They don't have to be single variables. And like in this case, b would have been 7. Now we also got another formula. It says a squared minus 2ab plus b squared is going to equal to a minus b squared. Now you could sit there and memorize a couple more formulas or just keep using the PSD and the key number to do those. So like I say, I'm not a real big fan of the perfect square trinomial, but I've shown you one example, so I've satisfied that requirement. Go to our second example. Okay, number 2, we got 49 m squared minus 9 n squared. Okay, GCF. 49 and 9, no GCF. Groupings, 4 more terms. That doesn't fit. PSD and key number are both 3 terms, so those don't fit. Difference 2 squares. 2 terms with a minus between it. 2 terms with a minus between it. That fits. It actually is more than just 2 terms. You can have anything with a minus between them. So, but you got 2 items with a minus between them. What we try to do with the difference of 2 squares, this is dots, is we try to rewrite this as something squared minus something else squared. Well, first thing we'll look at is 49. Well, 49 is 7 times 7. Then the m squared, m times m gives you m squared. The 9, 3 times 3 gives you 9. And the n squared, n times n gives you n squared. There's actually a formula associated with this, and almost nobody uses the formula. I'll label what's inside the first parentheses as f for first. I'll label what's in the last parentheses as l for last. And our formula looks like this. You take what's inside your first set of parentheses, you add what's in your last. You take what's inside your first and you subtract what's in your last. Now if I was using a formula, everywhere I had an f, I'll put in 7m. Everywhere I have an l, I'll put in 3m. But again, like I say, people usually think of it this way. You take what's inside your first set of parentheses, you add what's inside your last. You take what's inside your first, and you subtract what's in your last. And that's your answer. Let me grab a drink there. Let's look at our next problem. We got 4 s to the 10th minus 25 t to the 8th. Our first method is GCF. They don't have anything in common. Most of the times they won't, but you should look at it and see if they do before you really start any factoring problem. Groupings, 4 more terms. That doesn't fit. PSD and key number, both 3 terms. Well, this is 2 terms. And then we come down to our fifth method, difference 2 squares, 2 terms of minusing it. Well, that fits. So we're going to try to write this as something squared minus something else squared. Now I start with the first piece, 4. Well, 2 times 2 gives you 4. S to the 10th, that would be S to the 5th. Now, a very easy way to figure that out if you didn't see that is you take whatever powers here, the 10, and you divide by the 2, and that gives you what goes here. So 10 divided by 2 is 5, and we put 5 there. Now 25, that's 5 times 5. And t to the 8th, that'd be t to the 4th. Again, if you take the 8 divided by 2, that gives you 4. So this is what's in our first set of parentheses, and this is what's in our last set of parentheses. I'm not going to write the formula down. I personally like to just think of it what I just said before. You take what's inside your first set of parentheses, 2s to the 5th. You add what's in your last set of parentheses, so plus 5t to the 4th. And then you take what's inside your first set of parentheses, 2s to the 5th, and you subtract what's in your last set of parentheses, 5t to the 4th. And that's our answer. Let's take a look at our fourth problem. We got x to the 4th minus 81. Okay, GCF. They don't have anything common. Grouping. 4 more terms. This is 2 terms. PSD and key number, both 3 terms. That doesn't fit. So down to method 5. Difference 2 squares. 2 terms with a minus unit. Well, that fits. So we're going to try to write it as something squared minus something else squared. Well, this is x squared. Again, you could take 4 divided by 2 gives you 2. 9 times 9 gives you 81. So we'll take what's inside our first parentheses, we add what's in our last. And we take what's inside our first, and we subtract what's in our last. Now, looking over here at the end, we got x squared minus 9. This is the difference 2 squares again, 2 terms with minus in it. Specifically, x times x gives you x squared, and 3 times 3 gives you 9. So we're going to go through the process again. Try to write it as something squared minus something else squared, even though I've said it. X times x gives you x squared, and 3 times 3 gives you 9. Now the x squared plus 9 just carries down. It doesn't change at all. So we'll take what's inside our first set of parentheses, we add what's in our last, and take what's inside your first, and you subtract what's in your last. Now this x minus 3 is 2 terms with a minus in it, but nothing times self will give you 3. So we're done. Now over in this previous problem, number 3, the reason why I didn't go further, this is 2 terms of minus in it, but nothing times itself gives you 2. Nothing times itself gives you 5. So that's why we don't go further. You have to be able to look at this and say something times itself gives me this, something times itself gives me this. Let me start a new page. And let's look at problem number 5. Got 27 v to the 3rd plus 8. First method, GCF. There isn't anything. Grouping is 4 more terms. That doesn't fit. PSD and key number are both 3 terms, so that doesn't fit. Difference 2 squares, dots. 2 terms of minus between it. Well, there's a plus between this. Sixth method, difference 2 cubes. That's again 2 terms of minus between it. That doesn't fit. Last method, number 7, sum of 2 cubes. 2 terms with a plus between it. Well, that fits. So we're going to try to write this as something to the third power plus something else to the third power. Now, instead of asking yourself what times itself gives you this, you ask yourself what times itself 3 times gives you this. For like the 27. 3 times 3 times 3 gives you 27. V to the third. V times V times V gives you V to the third. And for the 8, 2 times 2 times 2 gives you the 8. So we were able to write it as something to the third power plus something else to the third power. Now I'm going to label this as F for what's in my first set of parentheses. I'll label this as L for what's in my last set of parentheses. And the formula for the sum of 2 cubes says we got F plus L times F squared minus FL plus L squared. And here you just wherever you have an F, you plug in 3V, and wherever you have an L, you'll plug in 2. So we're going to have 3V plus 2, and here we'll have 3V squared minus 3V times 2 plus 2 squared. So again, everywhere I have an F, I plug in 3V, and everywhere I have an L, I plug in 2. So we got 3V plus 2, 3V squared. Well, 3V times 3V gives me 9V squared. Minus 3 times 2 is 6V, and 2 squared gives us 4. And that's our answer. Let's look at our next problem. 27x to the third minus 64y to the third. First method, GCF. Well, they don't have anything in common. Let's see. Second method, grouping. 4 more terms. That didn't fit. PSD and key number, both 3 terms. Those don't fit. Fifth method, difference 2 squares. 2 terms of minusing it. That fits. Now, 8 times 8 gives you 64, but y to the third. What times itself gives you y to the third? Nothing. It fails. Nothing times itself gives you 27. So that fails. So then we go on. Our sixth method says difference of 2 cubes. Well, let's try that. Difference 2 cubes, 2 terms of minusing it. So we try to write it as something to the third power minus something else to the third power. Very similar to this previous problem. Well, 27 we saw. 27 is 3 times 3, which is 9, times another 3, which is 27. X to the third, x times x times x. 64, that would be 4. 4 times 4 is 16, times another 4 gives you 64. And y to the third, y times y times y. So we were able to write it as something to the third power minus something else to the third power. I'll label this as F for what's my first set of parentheses. I'll label that as L for what's my last set of parentheses. The formula for the difference of 2 cubes is F minus L times F squared plus FL plus L squared. Now everywhere there's an F, I'll plug in 3x, and everywhere there's an L, I'll plug in 4y. So we have 3x minus 4y times 3x squared plus 3x times 4y plus 4y squared. Then we'll do a little bit of simplifying. 3x squared, 3x times 3x gives me 9x squared, plus 3 times 4 is 12xy, 4y squared. 4y times 4y gives you 16y squared. And that'd be your answer. Now you can never factor these down further for your normal ones. Maybe if I had something really bizarre, maybe you could. It looks like you can factor down further, key number method, or perfect square trinomial, if you're used to that. But there'd have to be a 24 here in the middle. So it's always a little bit short. Here there would have to be a 12 in the middle. Let's look at our last problem. 48x to the third plus 3y to the sixth. Well, I skipped down to the very bottom. Sum of 2 cubes. 2 terms with a plus between it. But nothing times itself 3 times will give you 3. Nothing times 3 times will give you 48. So it must mean it's prime, means you can't factor. Or is it? Think what I've been emphasizing over and over. Our first method is GCF. A lot of problems, if you don't factor out GCF and you dive right into the method, well, it won't even factor sometimes. Sometimes it will. GCF, these both have a 3 in common. So I'll factor out a 3. And that gives us 16 x to the third plus y to the 6. Okay, now we go through the rest of our methods. Grouping is 4 more terms. That doesn't fit. We're looking at what's inside the parentheses now. PST, key number, both 3 terms. That doesn't fit. This is 2 terms. Fifth method, difference 2 squares, dots. 2 terms of minus string it. That doesn't fit. This is a plus. Difference 2 cubes. Sixth method. 2 terms of minus string it. That doesn't fit. We have a plus here. So last one. Method 7. 2 terms with a plus between them. That fits. So we're going to try to write this as something to the third power plus something else to the third power. Did I factor that out right? Doesn't work, does it? There's nothing times itself 3 times gives you 16. So this is our answer. I guess GCF is the only thing we can do on that. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. Nothing gives you 16. Boy, that's weird. I'll probably say that each semester when I'm showing that problem. Because it's in the method, but I mean, it does show you the process, the thought process to go through. But anyway, this is our answer. Assuming I wrote it down right. Yeah, I wrote it down right. Take a 3 out. Oh well. That's the end of that section. Factoring special products.